Hello everyone, good evening guys. So please tell me whether audio and video is clear to you. Am I audible? So please comment in the chat section. Please tell me guys, am I audible? I think audio is clear. Okay, so let's proceed today's session. So in the previous session, we have discussed about Ohm's law, and we have discussed about resistance. So in today's session, we will discuss more about resistance. Okay, so let's wait for maybe some 2-3 minutes so that everybody can join, and then we'll start the session. Till then, I can complete the introduction part. Okay, so today's session is about equivalent resistance calculation, but before that, I will tell you about temperature dependence of resistance. I have to tell you about that. And then we will take different cases of equivalent resistance, how to calculate equivalent resistance. Okay. So we'll take that into consideration. Okay. This is my introduction. I teach almost every subject in electrical engineering. So right now I'm teaching network theory. I hope you are enjoying. Okay. Let's proceed. Yes, this series is fundamental series. In this series, you'll get the fundamental subjects like network, signal control, digital electronics. Okay, so those subjects will be covered under this series. Okay, and the first subject is network theory. So it's important subject, and I hope you are enjoying. I have covered one lecture. Those students who have not attended the previous lecture, please watch it. That lecture is based on Ohm's law and charges and current. Okay. Let me tell you guys, there is one scholarship test which will be on 5th of March at 12 p.m. So you can register for that, and you can get 90% scholarship if you are a needy student. If you are financially not strong and you want to, if you want the scholarship, you can attempt this test and you can get up to 90% scholarship. Okay. Before starting the session, please subscribe our channel and like this session if you haven't liked it, and press the bell icon so that you get the notifications. Okay, so tell me guys, can I start the session? Tell me everyone, can I start the session? You ready? Tell me, you ready? Okay, before starting the session, let me tell you guys, there is one series, Experiment and Beyond. You can search that series on YouTube, Experiment and Beyond by Ashu Sir. Okay. In that series, I have performed experiments on network theory. You have to watch the first lecture of that series. Okay. And you can watch the experiment so that you can understand it better. The series name is Experiment and Beyond. Experiment and Beyond. Okay. So you can watch that series, and you can watch that first lecture. I hope you will enjoy that. And this is all about experiment and nothing else. Okay. So let's start the session, guys. I think all the students have joined, and the other student will join later. So let's start the session. In the previous class, I told you about resistance, and I told you about Ohm's law. I told you that whenever you have a metallic body, let's say you have some metallic block and the length of the block is L and the cross-section area is A and the resistivity of the material is rho. Now, if you fix these three things, resistivity depend on the type of metal. Let's say this metal is aluminum or copper or maybe iron. Okay. So if you fix these three things, it means its resistance is fixed. R is fixed, rho L by A. Okay. Its resistance is fixed. Resistance is independent of voltage and current. We have discussed that. And in Ohm's law, we have discussed that if you apply some potential difference across this metal block, let's say this is at higher potential, this is at lower potential, and the potential difference is V volt. If you applied a potential difference of V volt between these two terminals, then there will be a current flow. There will be a current flow. And that current will be proportional to the voltage difference between these 2 points. And that proportionality constant can be replaced, this proportionality sign can be replaced with proportionality constant and the proportionality constant will be 1 by R. Okay, so this is my Ohm's law. So you can say that V is equal to IR. V is equal to IR is the Ohm's law. This is the Ohm's law in difference form. We call it difference form because the potential, this V is the potential difference. You require 2 points to apply this formula. That's why we call it difference form. Okay, because in this form, V is the potential difference. It is the difference between 2 points. Can you apply Ohm's law at some point? At some point? Yes, at some point also, at some particular point also, you can apply Ohm's law. In point form, Ohm's law can be represented as J equal to sigma E. J equal to sigma E. Now what is this J? J is conduction current density. J is conduction current density. Sigma is conductivity. E is electric field. I'm not going to prove this. I'm not going to prove this because it will take much time and I don't want to devote time on this because it's a part of electromagnetic field theory. Okay. So J equal to sigma is the Ohm's law again, but it is in point form. What does it mean? It means using this expression, I mean, if you look at this expression, electric field at some point can be defined, conductivity at some point can be defined, and the current density at that point can be calculated. Okay. So J equal to sigma E is the Ohm's law in point form. This can be applied on a point, but this cannot be applied on a point because you require a difference, potential difference between these 2 points, between the 2 points. That's why you can say this is in difference form, this is in point form. From this relation, you can derive this relation also. Because this current density, what is the current density? Current density is current per unit area of cross section. Sigma is 1 upon rho. It's opposite to resistivity. Conductivity is opposite to the resistivity. And electric field is V by L. Electric field is potential difference per unit length. In L length, the potential difference is V volt. So under unit length, the potential difference will be V by L. From this, you can calculate that I is equal to V upon R. It's simple. Okay. So I hope it is clear. So in the previous lecture, we have discussed about this Ohm's law. Okay. So now I'm telling you that Ohm's law can be represented in two ways, J equal to sigma E and V is equal to IR. Okay. Now in the previous lecture, I also told you that R is the resistance of the metal block. If you fix these three things, R is fixed. R is independent of V and I. What does it mean? If you fix the block, the length and the area and the resistivity, it means resistance is fixed. Now if you apply the potential difference V across this block, then the current will be such that the ratio V upon I will be fixed and it will be equal to R only. Okay. The ratio will be R only. I hope it is clear. It means R does not depend on V and I. Actually, if you apply some voltage V, then I will be according to R. It means I will be such that this ratio came out to be the fixed quantity R. I hope it is clear. Now, in the previous class, I gave you a homework question. And that homework question was, if you look at that homework question was, can you measure the resistance of a bulb, let's say. I mean, can you say that the resistance of this bulb is like 20 ohm or 30 ohm or 100 ohm? Can you say like that? Answer is yes. You can say that the resistance of the bulb is like 60 ohm or 100 ohm. But then you have to mention the temperature because this resistance is a strong function of temperature. It varies with the temperature. Okay. This resistance is a function of temperature. If you look at this resistivity is a function of temperature. That's why if the temperature of this metal is increasing, if the temperature of this metal increases, the resistivity will also increase and so the resistance will also change. The resistivity will change. It will not increase. Excuse me. Let me repeat the line. If you are increasing the temperature of this block, then the resistivity of this block will change. And if the resistivity is changing, then the resistance will also change. Okay. It means resistance is a function of temperature. Resistance is a function of temperature. If the resistance is a function of temperature, then there is no meaning of saying that the metal block or some some circuit has this much of resistance. There is no point in that. Let's say I have some circuit. Let's say this is the circuit. Let's say this is 10 ohm. There is no point. In practical case, you cannot say that some material has 10 ohm resistance. You have to mention the temperature also. That at this particular temperature, this resistance is 10 ohm. Because if somehow the temperature is changed, then the resistance value will itself change. Okay? It means practically it is difficult to measure the resistance. If the circuit is working, let's say some circuit is working. If the circuit is working, let's say there is some circuit, and you went to the market, and from the market you purchased some resistance. Let's say this is 10 ohm, this is 20 ohm, this is 15 ohm, and this is 10 ohm. Now these values are at some particular temperature. Let's say room temperature. This is the value of this resistance, this is the value of this resistance, and this is the value of this. Okay, now what you did is you connect a source. You connected a source. If some source is connected here, obviously the current will flow. The current will flow. I am not interested in calculating the current, but surely the current will flow. If the current is flowing, then there will be a heat loss in the resistance, I square R loss. I will teach you from where this loss came, but for the time being, let's assume that in resistance, whenever the current flows, it will give you heat loss. Whenever we have resistance, and if some current is flowing through this resistance, it will give you some heat loss, I square R loss. It means the temperature of the resistance will be increased. If the temperature of this resistance is increased or this resistance is increased, then what will happen? The resistance value will change. It means whatever value you have used, they are no longer applicable. It has changed. The value has changed. I hope it is clear. Okay. So you can say that the resistance itself is a strong function of temperature. Okay. So in practical situation, there is no point of, you can't calculate the circuit resistance, and you cannot represent the circuit resistance like this. Why? Because they are at some particular temperature. If the temperature changes, everything will change. Circuit behavior, the current voltage, everything will change. Okay. I hope it is clear. Okay. What is the used in practical world with high precision? Okay, let's take this doubt also. But before that, there are some doubts you have posted. So let me read those doubts. Aman Ruke, we can calculate resistance of bulb only at specific temperature. Yes, because resistance changes with temperature. That's correct. That's correct. Totally correct. Okay. Okay. But after reaching a particular temperature, bulb resistance become calculated. Yes, after reaching some particular temperature, you can calculate the resistance, but you have to wait for that time. Okay, let me tell you one more thing. Guys, about resistance. Let me tell you one more thing about resistance. Look, every resistance has its rating. Let's say you have the bulb. Bulb is a form of resistance. Bulb. This bulb can be represented like this. Bulb is a resistance. The bulb that you must have seen, the 10 rupee bulb. Okay. The filament bulb. Now, this bulb can be represented as a resistance. On this bulb, whenever you go to the market, then it is written that 60 watt to 20 volt. What is the meaning of that? What is the meaning of that? 60 watt to 20 volt. What is the meaning of that? The meaning of this thing is, it's a resistance. Whenever you apply a potential difference across it, there will be a current flow. There will be a current flow. If there is a current flow, there will be heat dissipation. Power will be lost in this resistance. This resistance will consume the power. It will consume the energy, you can say. And that energy will be dissipated as heat. So you can say that the power lost in the resistance is I square R. Power loss is I square R. Now, what is the meaning of this 60 watt? The 60 watt means it is the rating of this bulb. It is the rating of this resistance. It means it can handle 60 watt of power. At 220 volt, the current will be such that the power loss in this bulb is 60 watt. The meaning of this line is, if you apply 220 volt across the bulb, the current will be such that the power in the bulb will be at 60 watt. But there is one more meaning of this line, and the meaning is, if somehow you can increase the power loss, let's say the voltage is increased beyond 220 volt, let's say voltage is 250 volt or maybe 300 volt. If you increase the voltage across the bulb, then the power loss in the bulb will also increase, because the current will also increase according to Ohm's law. Okay, let's say you increase this voltage. If voltage is increased, obviously the current will also increase. What does it mean? If current is increased, then the power loss in the resistance will also increase. It means if voltage is increasing, power will go beyond 60 watt. There is a probability of burning of the filament of this bulb. It means it is the rating of this filament. It is the rating. It can handle power loss up to 60 watt. If the power in this filament, ideally, if the power in this filament is increased from 60 watt, this filament will be burnt out. It means for every resistance, there will be some power rating. For every resistance, there will be some power rating that it can handle this much of power. Why there is a power rating? Why we require that power rating? Why we require? You must have seen now that BJT of 10 milliwatt. Every element has power rating. Like AC has power rating of 1500 watt. If the AC is 1.5 ton, then you can say it's approximately 1500 watt. So I can say that every resistance has its power rating. Now you have to understand the meaning of power rating. What is the meaning of power rating? Power rating means it can handle the power up to this level. If somehow that power loss is increased, if the power loss in this bulb is increased, it is beyond 60 watt, then it may burn. Okay, it cannot handle that power. Now you will ask me, sir, why not? What's the problem with that? If I increase the power loss, then why it will not handle that power? Okay. Can you tell me why there is a rise in temperature of some, let's say there is some body, let's say this is the remote, and the temperature of this remote is increasing. Why there is a increase in temperature? Obviously, let's say you have some body. Let's say you have some body and you put fire on this. You put fire on this body, okay? If the fire is put here, then the temperature of this body will rise. Now, up to what point this temperature will rise? Will keep on rising? Tell me. Or let's not take this. Let's say it's a human body. Let's say it's a human body, and the temperature of the body is rising. Why it's rising? Or maybe let's not take human body. Maybe take some other. Let's say there is some closed body, and in that body there is some heat is generated. There is some heat is generated inside this body. If heat is generated inside that body, obviously there will be temperature rise. But that temperature rise will be up to some level. Beyond that, the temperature will not rise. Can you calculate that level? Up to what level the temperature will rise? How to calculate that level? It's very simple. If the rate of generation of heat and the rate of dissipation of heat become equal, if the rate of generation of heat and the dissipation of heat become equal, at that point the temperature will not rise. Temperature will become constant. If the generation rate of the heat and the dissipation rate of the heat become equal, then the temperature of the body will not increase. In my body or your body, our temperature is fixed. Generally, our body temperature is fixed, because inside our body there is some heat generation, because there are some chemical reactions which are going on. So there will be some heat generation. But the dissipation of our body heat, the dissipation is also same. If the generation rate and the dissipation rate become equal, then the temperature of the body become constant. But let's say the generation rate is higher than the dissipation rate. If the generation rate is higher than the dissipation rate, then the temperature will keep on increasing. The temperature will keep on increasing. Okay, I hope it is clear. Why the temperature of somebody, anybody will increase? because the generation rate of the heat is greater than the dissipation rate. Now in this case of bulb, let's say we have applied some higher voltage, more than 220 volt. Let's say I have applied 300 volt here. If the voltage is 300 volt, obviously the current will be large and the heat dissipation in this resistance will be large. Let's say the heat dissipation goes to maybe 80 watt. Let's take a rough number. Okay, I'm not calculating this, I'm just taking roughly. Let's say at 300 volt, the heat dissipation is 80 watt. What does it mean? It means the heat generated, the generation rate is large than the dissipation. This much of heat, this bulb cannot dissipate in the medium. This much of power, it cannot dissipate in the medium uniformly, continuously. Because the maximum rate by which it can dissipate the heat is 60 watt. Okay, the 60 watt power it can dissipate easily. But if the power loss is beyond 60 watt, what does it mean? It means the dissipation rate is less than the generation rate of the heat. And what will happen then? Then the temperature will keep on rising. If the temperature will keep on rising, at one point of time the filament will burn out. Okay, I hope it is clear why the temperature will rise, why the temperature of some body will rise. Okay, so exactly in this resistance, its rating is 60 watt. What does it mean? It means if the 60 watt is generated inside this, if 60 watt heat, actually 60 watt is power, it's not heat, but you can equivalently say it as a heat. Okay, so if 60 watt heat is generated inside that bulb, then it can easily dissipate in the medium. But if the heat generation is more than 60 watt, obviously it will not be able to dissipate that much of heat, and at one point of time the temperature will keep on rising, and at one point of time that filament will burn out. Okay, so you have to be careful about that. This is the rating of the bulb. I hope it is clear. Let's proceed, guys. Now I told you that, so this is about the rating of any resistance. Now let's come back. I told you in the previous class that we have actually two wires. I have taken one copper wire whose cross section area was A and the length was L, if you remember. Then what I did is I elongated that such that the length become 2L. Now the length is 2L. Same copper wire, I have elongated that. Okay, I have stretched that such that the length become 2L. Now if the length become 2L, then the area of cross section will become A by 2, if you remember. In this case, let's say the resistance is R, then in this case the resistance will be 4R. I hope it is clear. In this case the resistance will be 4R. It means if the wire cross section is reduced, if the wire is thinner, if the wire cross section is reduced, the resistance will be large. Now I told you that if there is a load, and that load demand high amount of current, let's say 15 ampere, let's say this load is AC, air conditioner. Okay, if this load is AC, it demands high amount of current. So if it demands high amount of current, then this wire, the connecting wire, should be of high cross section area, large cross section area. Why? Because if the cross section area of the wire is thin, then the resistance of the wire itself is very large, and if the resistance is very large, then the heat loss, because of this 15 ampere, the heat loss in this wire will be large, and that heat loss may damage the wire. The wire will be burnt out. Okay, I hope it is clear, guys. I hope it is clear. That's why whenever you have large amount of current, if the load is demanding the large amount of current, then there you have to use the more cross section area wire. Okay, I hope it is clear. Okay, let's come back to the original situation. So now I told you that the resistance is a strong function of temperature. Now the question is how the resistance will change with temperature. Let's discuss about that. How the resistance changes with temperature. For any particular metal, let's say this is the temperature and this is the resistance. This is the resistance, and I want to plot the variation of resistance with temperature. So for any metal, if you take metal, If you take the case of metals, in any metal, the variation will be like this. The variation will be like this. It means with temperature, the resistance will rise. Let's say that this resistance is maybe R naught. R naught is resistance at T equal to 0. Let's not call it, don't confuse with this R naught and this R naught. This R naught is different. Okay. Let's not look at this relation. For the time being, let's not look at this relation. I'll come back to this relation. But let's say at 0 degree centigrade, the resistance of the metal is R naught. The resistance of this metal is R naught. If the temperature of this metal is increased, the resistance will keep on increasing. Let's say at some temperature T naught or at some temperature T, the resistance is RT. The resistance is RT. Okay. Now what I need to do is, I need to draw a relation. I need to draw a relation of RT. I need to write RT in terms of R naught. How to write RT in terms of R naught? That is very simple. You need to write the equation of this line. So if you write the equation of this line, then what you can do is you can write it easily. Let's say if I extrapolate this line, this point will be minus T naught. Let's call it minus T naught. Now you will ask me, sir, why you are extrapolating this? Actually, I want to calculate the slope of this line. Though slope can be calculated from this point also, I mean these 2 points also, slope you can easily calculate. So if you want to write the equation of this line, then the equation will be, let me write the equation, RT will be equal to R naught into 1 plus 1 by T naught into T. I hope it is clear. So you can say that RT is equal to R naught into 1 plus 1 by T naught into T. You can check that relation. Now you'll ask me, sir, how you have written this? It's very simple. What you can do is, let's calculate the slope of this line. Okay, the slope of this line, let's say this is one point and this is the other point. Okay, so this is one point, this is point A, this is point B. Now what is the slope of this line? Slope of this line is change in height from this point to this point. The change in height is RT divided by the change in temperature. Change in temperature is T plus T naught. Okay, so this is the slope. This is the slope of this line. Slope into T. I told you how to write the equation of the line. The slope into T. Now, is this equation correct? No, sir. Why not? Because at T equal to 0, the value has to be equal to R naught. But if you put T equal to 0 in this line, at T equal to 0, it is R naught upon T naught. R naught upon T naught. But it has to be equal to, tell me guys, it has to be equal to R naught. Okay. Then you have to change. You have to change in this equation. You have to change something in this equation so that the equation can satisfy this point. I hope it is clear. So if you write this equation, you can see that the equation has to be like this. This is the equation of this straight line, and you can check it. If you put T equal to 0, on both sides, then this will become R0. This will be equal to R0, and you can see that the left side and the right side will be equal. Okay, I hope it is clear. So this is the equation of the straight line. This is the equation of the straight line. It means RT, this RT will be equal to R naught into 1 plus 1 by T naught into T. Now this 1 by T naught is known as alpha naught. Okay, so you can write it like this. RT is equal to R naught into 1 plus alpha naught into T. Now what is this alpha naught? Alpha naught is the temperature coefficient. We call it temperature coefficient at T equal to 0 at this point. Okay, alpha naught is the temperature coefficient at T equal to T naught. Okay, alpha naught we call it temperature coefficient at T equal to 0, at 0 degree centigrade. Okay, at 0 degree centigrade the temperature coefficient is alpha naught. Okay, and R naught is the resistance value at T equal to 0. I hope it is clear. So you can write the resistance at some temperature T, that will be equal to resistance at 0 degree centigrade plus into 1 plus alpha naught into T. T is the change in temperature from 0 to T. You are going from 0 to T. So this is the resistance at some temperature T. Now the question is, let's say you are not moving from 0 degree to T. Let's say you are moving from T1 to T. T1 to T2. Let's say you know the resistance value at some RT1, at some temperature T1, you know the resistance value RT1, and you need to calculate the resistance value at some temperature RT2. You need to calculate this RT2. Then what should I write? How should I write this equation? Then it's very simple. What you can do is you can write it like this. RT2 will be equal to RT1, because you know the value of T1. You know the value of resistance at T equal to T1. You know this value. You don't know the value of the resistance at T equal to 0. You know the value of the resistance at T equal to T1. So RT2 will be equal to RT1 into 1 plus alpha T1 into T2 minus T1. Okay, this will be my resistance value at T2. At temperature T2, if you know the resistance value at temperature T1, let's say, if you know the resistance value at temperature T1, then the resistance value at temperature T2 will be equal to RT1 into 1 plus alpha T1. It means the temperature coefficient should be at alpha T1, at this temperature. You should know the temperature coefficient. Alpha T1 into T2 minus T1. Okay, and this will also satisfy this relation. You can check that. Let's say this T1 is 0 and T2 is T. If you put T2 equal to T and T1 as 0, you will get the same relation. Okay, if you put T1 equal to 0 and T2 equal to T, you will get the same relation. So you can say that from this relation I have derived this relation. Okay, and this is the general relation. I hope it is clear, guys. I hope it is clear. Let me repeat this again. Let's come to the next slide. Let me repeat this again. How the resistance is dependent on temperature. For any metal, the resistance changes with temperature like this. The resistance changes with temperature. This is not time, this is temperature in degree centigrade. So at 0 degree centigrade, you can see that the resistance, let's say R naught. At some time T, at some temperature T, the resistance is RT. Now I want to write this RT in terms of R naught. How to write this? What you can do is you can extrapolate this line, and this instant is, let's say, minus T naught. Now if you write this equation, then RT can be equal to R naught into 1 plus 1 by T naught into T. You can check. This is the equation of this line. At T equal to 0, this RT has to be equal to R naught. You can see that. If you put T equal to 0 on this side, this is gone. Okay, this is gone. So on this side you have R naught only, and we know that at T equal to 0, it has to be R naught. The temperature RT has to be equal to R naught. Okay, I think it is clear. So at some temperature T, you can calculate the resistance like using this relation. Now, what is this 1 by T naught? I call this 1 by T naught as alpha naught. What is alpha naught? Alpha naught is the temperature coefficient at T equal to 0. At T equal to 0 degree centigrade. Okay, alpha naught is the temperature coefficient at T equal to 0. So if you know the resistance value at T equal to 0 degree centigrade and you know the alpha naught, then you can calculate the resistance value at some other temperature T. It's easy peasy. But let's say you don't know this resistance at T equal to 0. R naught is unknown and alpha naught is unknown. What you know is, let's say you know this T1 temperature resistance, RT1. Let's say you know this RT1. And we need to calculate this RT2. How to calculate this RT2? We need to calculate this RT2. It means you know the resistance value at temperature T1. And we need to calculate the resistance value at some other temperature T2. Now how should I write this equation? How should I change this equation? It's very simple, guys. What you can do is RT2 is equal to RT1 into 1 plus alpha T1 T2 minus T1. Okay, this will be the equation now. And you can check that this will also satisfy this relation. How to check? How to verify? It's very simple. What you can do is you can take this T1 to 0 and T2 to T. If you put T1 as 0 and T2 to T, then this relation is valid, na? So in this equation, if you put T1 equal to 0, this is gone. T2 can be replaced with T, and since T1 is 0, this will become alpha naught and this will become R naught. So you will get the above equation. It means from this relation you can derive this relation also. I hope it is clear. What I have done is I have used the straight line relation, nothing else. Okay? Okay? It means the important point is, let's say you know the temperature coefficient at T equal to 0. Then this R naught has to be the resistance at temperature 0 degree centigrade. Okay? If you know the temperature coefficient at some T1, then this resistance has to be T1. Okay? It is important. You cannot say that I put this alpha as alpha T1 and this I can put alpha R naught. No, it's not correct. Because the starting point is T1 now. So at that time T1, at that temperature T1, you have to check the temperature coefficient. At that temperature T1, you have to check the temperature coefficient T1. And at the same temperature, you have to know this value RT1. Then only you can calculate the resistance value RT2. I hope it is clear. Okay. I hope it is clear. Okay. I hope it is clear. No, I'm not saying that alpha is positive. Alpha can be negative. It can be negative. It can be positive. Okay. But for the time being, I have taken it positive because I'm discussing about metals. I'm discussing about metals. In metals, temperature coefficient is positive. Okay. So that's why I'm discussing about metals. So I told you that this is the relation. Now the problem is this alpha naught and this alpha T1 are not equal. Alpha naught is the temperature coefficient at T equal to 0 degree and alpha T1 is the temperature coefficient at T equal to T1, at T1 temperature. They are not same. They are not same. We have to calculate the relation between alpha naught and alpha T1. We have to calculate the relation between alpha naught and alpha T1. Okay? Because you cannot put this alpha naught value at this position. I hope it is clear. How to calculate this alpha naught and alpha T1. I mean, how to calculate the relation, how to find the relation between alpha T1 and alpha naught. How to do that? Tell me guys, what should I do? What should I do? How to calculate that? How to calculate that? Is there any way? Is there any way to calculate the relation between alpha T1 and alpha naught? Think about it. Think about it. सर इस कंसेप्ट पे एक न्यूमेरिकल करवा दो. मैं एक न्यूमेरिकल करवा दूंगा. ठीक है सर. बाय द इक्वेशन ऑफ स्ट्रेट लाइन alpha is slope is constant now. Actually, if you look at this, the slope is R naught by T naught. The slope of this line is R naught by T naught. It's not 1 by T naught. It's not alpha naught. Alpha naught is not only the slope. Alpha naught is not only the slope. Actually, the slope is R naught by T naught. R naught by T naught. Okay. This is the main problem. Anyway, so the question is how to calculate the relation between alpha naught and alpha T1. Can you tell me? Tell me guys, how to find this relation? How to find this relation? Is there any way? बताएं भाई क्या रिलेशन आएगी इसमें, इन दोनों में क्या रिलेशन आएगी? मैं आपको बता देता हूं. Let me tell you guys, there is a relation between alpha T1 and alpha naught, and how to write that relation? That relation is very simple. Alpha at some temperature T will be equal to alpha naught divided by 1 plus alpha naught into T. This is the relation. It means if you know the temperature coefficient at T equal to 0, अगर आप T equal to 0 पे temperature coefficient को जानते हो, तो किसी भी different temperature पे अगर आपको temperature coefficient निकालना होगा, तो आप इस relation से निकाल सकते हो. इस relation से आप किसी भी different temperature पे temperature coefficient आप निकाल सकते हो दोस्तों. अब ये relation आई कहां से? क्या आप इसको derive कर सकते हो? Can you derive this relation? ये relation कहां से आई है? And let me tell you guys, there is one more interesting point. इस relation से आप ये भी बता सकते हो कि temperature coefficient की जो maximum value होगी, the maximum value of the temperature coefficient will be at T equal to 0. जब मेरा टेम्परेचर 0 होगा वहां पे अल्फा टी की मैक्सिमम वैल्यू आएगी एंड दैट इज अल्फा नोट. अगर मैं टेम्परेचर को बढ़ाना शुरू कर दूंगा, इफ टी इज इंक्रीज्ड, अगर मैं टेम्परेचर को इंक्रीज करना स्टार्ट करूंगा देन अल्फा टी विल लेस देन अल्फा नोट, अल्फा टी जो है वो अल्फा नोट से लेस हो जाएगा. नाउ द क्वेश्चन इज फ्रॉम वेयर आई हैव रिटन दिस, थिंक अबाउट इट, थिंक अबाउट इट. मैंने इसको कैसे लिख दिया, ये कहां से आई है रिलेशन? तो ये आपका होमवर्क है. ओके, दिस इज योर होमवर्क, यू कैन फाइंड इट इन माई सम ओल्ड लेक्चर्स. मैं इसमें नहीं जाना चाहता दोस्तों, बट यू शुड नो दैट देयर इज अ रिलेशन बिटवीन अल्फा नोट एंड अल्फा T1. If I want to calculate this alpha T1 will be equal to alpha naught divided by 1 plus alpha naught into T1. Okay, this way you can calculate this alpha T1. I hope it is clear. Okay, so I don't want to derive it. This is your homework, you have to derive it. If you want some help, then I can send you the PDF, because I have the entire derivation on my page. Okay, I have derived it. So I don't want to copy it and I don't want to tell you about the derivation, but you should derive. So this is the relation that you need to remember. This is the relation that you need to remember. But there are some students who make mistake, who do some mistake. What they do is, remember, you are moving from T1 to T2. So this temperature coefficient has to be at T1 temperature. This temperature coefficient has to be at temperature T1. You cannot take it alpha T2. Okay, this temperature coefficient has to be at temperature T1. I hope it is clear. I hope it is clear. Okay, so please be careful guys, please be careful. Okay, don't make mistake. अब आइए यहां पे देखिए, this was the relation. Now in this relation R is equal to R naught into 1 plus alpha T minus T naught. Now tell me, there should be a correction in this relation. Alpha naught I should write. Alpha naught is the temperature coefficient at some temperature T naught. And what is this R naught resistance? R naught resistance is the resistance of the material at temperature T naught. Okay, is it clear guys? So please be careful. And this R naught and this R naught is not same. This R naught is at temperature 0 degree centigrade, but this R naught is resistance at T naught temperature. Okay, so you have to be careful guys, you have to be careful while applying this relation. Please be careful. ओके, प्लीज बी केयरफुल. मैं आपको फिर से बता देता हूं, जब भी आप रेजिस्टेंस को टेम्परेचर के साथ देखना चाहते हैं कि रेजिस्टेंस कैसे मेरा टेम्परेचर के साथ बदलेगा, तो आपको थोड़ा केयरफुल होना है. कैसे केयरफुल होना है वो जरा मैं रिलेशन फिर से बता देता हूं. जरा देखिए दोस्तों, वेट अ मिनट. हाँ, जो रिलेशन है दोस्तों वो क्या होगी, सुनिए. जो रिलेशन है वो मैं आपको थोड़ा सा बता देता हूं, इसको मैं थोड़ा आगे लेके चलता हूं. हाँ जी, जरा देखिए दोस्तों, रिलेशन कुछ इस तरह की बनेगी. रेजिस्टेंस एट सम टेम्परेचर T2, किसी भी टेम्परेचर T2 पे जो रेजिस्टेंस आएगा, दैट हैज टू बी इक्वल टू रेजिस्टेंस एट सम टेम्परेचर T1 इनटू 1 प्लस अल्फा T1. टेम्परेचर T1 पे ही आपको टेम्परेचर कोएफिशिएंट पता होना चाहिए, इनटू T2 माइनस T1. आई होप इट इज क्लियर. ओके, दिस विल बी द रिलेशन. अब जरूरी नहीं है कि आपको टेम्परेचर कोएफिशिएंट जो है वो T1 पे ही दे. ऐसा हो सकता है कि टेम्परेचर कोएफिशिएंट आपको 0 डिग्री पे दे दे. इफ 0 डिग्री पे टेम्परेचर कोएफिशिएंट दे रखा है, देन यू नीड टू कैलकुलेट दिस अल्फा T1. दैट हैज टू बी इक्वल टू अल्फा नॉट डिवाइड बाय 1 प्लस अल्फा नॉट इनटू T1. सही है, इस तरह से आप अल्फा T1 को कैलकुलेट करेंगे, देन ओनली यू विल पुट इट हियर एंड देन ओनली यू विल कैलकुलेट दिस रेजिस्टेंस. आई होप इट इज क्लियर. बताइए दोस्तों, तो ये बड़ा इंपॉर्टेंट रिलेशन है, इसको याद रखिए भाई. और इसको कैसे याद रखना है मैंने आपको बता दिया है. बिकॉज जनरली ये जो अल्फा है ये कांस्टेंट नहीं होता, इट्स अ फंक्शन ऑफ टेम्परेचर. ये भी आपका फंक्शन ऑफ टेम्परेचर होता है. ये जो 0 डिग्री पे जो अल्फा होता है वही आपका T1 पे अल्फा नहीं होता. प्लीज ट्राई टू रिमेंबर दैट. ओके, आई होप इट इज क्लियर. नाउ दिस पार्ट इज ओवर. I told you what is the relation of the resistance with temperature. Okay, I told you the relation of the resistance with temperature. Now let's move ahead, and now it's time for the parallel and series combination. चलिए दोस्तों, अच्छा इसका डेरिवेशन देख लीजिएगा भाई. इसका डेरिवेशन कहां देखेंगे? I have derived it on YouTube also. You can search my old lectures. There you will find the derivation. But generally derivation ज्यादातर स्टूडेंट याद भी नहीं रखते हैं, तो आप इसको स्किप भी कर सकते हो. बस आप ये रिलेशन याद रखिए, मेरा कंसर्न बस ये है. ओके, लेट्स कम टू द नेक्स्ट थिंग. एंड नेक्स्ट थिंग इज सीरीज एंड पैरेलल कैलकुलेशन. series and parallel equivalent of the resistance. Whenever two resistances are connected back to back like this, जब दो resistance back to back connect हों, whenever the two resistance are connected like this, R1 and after R1 this is R2, then the equivalent resistance will be R1 plus R2. You can replace this entire branch with the total resistance as R1 plus R2. And whenever the two resistances are like this, R1 R2, जब भी पैरेलल में हो, पैरेलल में कैसे चेक करेंगे? Whenever they have the same starting point and the same end point, they have the same starting point and they have the same end point, we call it parallel connection. And in parallel connection, the equivalent resistance is R1 R2 divided by R1 plus R2. Okay, R1 R2 divided by R, or simply you can write it like this: 1 over 1 by R1 plus 1 by R2. Okay, it's very simple. Now let's say there are three resistances in parallel, R1, R2, R3. They are in parallel. Let's say R1, R2, R3. How to calculate their equivalent? Their equivalent will be equal to 1 upon 1 by R1 plus 1 by R2 plus 1 by R3. Okay, you can write it like this. क्योंकि ज्यादातर स्टूडेंट को इसी में कंफ्यूजन रहता है. They write it like this: R1, R2, R3, R1, R2, R3 divided by R1 plus R2 plus R3. R1 plus R. This is wrong. This is not correct. Okay, this is not correct. So आपको कैसे लिखना है? इस तरह से आप लिख लीजिए and उसको simplify कर सकते हैं आप. Okay, so please be careful, guys. So whenever the two resistances are in parallel, how to recognize that the two resistances are in parallel? They have the same starting point and they have the same end point. Then we call it parallel. Okay, and the equivalent resistance will be R1 R2 divided by R1 plus R2. Whenever two resistances are in series, back to back connection, if there is no current division, whatever current is here, the same current is flowing here. There is no division. The current is same. Okay, then we call it series connection, and in that series connection the total resistance is R1 plus R2. Now in any problem, let's say there is some problem like this and we need to calculate RAB. How to calculate RAB? What you need to do is you have to simplify this circuit. You have to find this series connection and parallel connection. You have to search for that. आपको देखना है कि इसमें सीरीज कहां है और पैरेलल कहां है. शुरुआत छोटे से कीजिए. Start from this, either this series part or this parallel part. Start from that. और वहां से फिर आप स्टार्ट करेंगे. इजीली ये आपका मोल्ड हो जाए, क्वेश्चन इजी बनता चला जाएगा. Okay, now let's look at this problem. Now in this problem, can you see this 10 ohm and this 10 ohm? Now you can see that this 10 ohm and this 10 ohm are connected back to back. They are connected back to back. After this resistance will start. There is no current division. Whatever current will go in this resistance, the same current will go in this resistance. So you can say that these two resistances are in series. So better solve these two first. Write the equivalent of these two resistances. So now tell me, what is the equivalent resistance of these two values? These two resistances? It's 20 ohm. Between these 2 points, this point and this point, the equivalent resistance is 20 ohm. So you can replace this entire branch with 20 ohm. So now the circuit will look like this. Now the circuit will look like this: 5. Here you have 20, and there is one more 20 here. There is one more 20 ohm here. Is it clear, guys? Now this is the circuit. Now can you see this 20 and 20? They are in parallel again. They have the same starting point and they have the same end point. So we call it parallel. Now tell me, if they are in parallel, what is their equivalent resistance? 20 into 20 divided by 20 plus 20. That is 10. 20 into 20 divided by 20 plus 20. Okay. So the answer is 10. So what you can do is you can replace this with 10 ohm. And this is 5 ohm. Okay. Now the equivalent resistance between these two points A and B will be 15 ohm. Because you can see that this 5 and 10 are in series. So it's easy peasy. Okay. I hope it is clear. So you have to recognize which branch is in series, which branch is in parallel. Okay. Once you get this branch now, that this is the series. We know that this is the series. Please solve this. Solve it first. Don't bother about the other circuit. Since you get this simple path, I mean the simple branch in which the two resistors are connected in series. So first combine them. After combination, you can replace it by 20 ohm, and then you will see that these two resistors are in parallel. Okay. So you can combine them. You can replace it with 10 ohm, and then this 5 and 10 ohm will be in series. So the equivalent resistance will be 15 ohm. It's easy peasy. Okay. I hope it is clear. Let's take one more question. Let's say I have the circuit like this. Let's say the circuit is like this. This is 10 ohm, 10 ohm, 20 ohm, 10 ohm, 10 ohm, 10 ohm, 5 ohm, 10 ohm, 5 ohm. This point is A, this point is B. Please tell me what is RAB. Please tell me RAB. What is RAB? Do it fast, guys. What is RAB? Tell me the equivalent resistance, RAB. Do it fast. It's very simple. Tell me the equivalent resistance value. RAB. What is RAB? Tell me, guys, what is RAB? Do it fast. 10 is your favorite number. It's not like that. Tell me, guys. Tell me, what is RAB? What is RAB? Please find the series and the parallel combination. Find the series and the parallel combination, nothing else. I think it's difficult in this situation. Okay, let's make it simple. Let's make it a little bit simple. Okay. Now tell me. Okay, maybe if I connect this point at this point, then it will be difficult for you to analyze this circuit. So better you connect this point with this point now. Now tell me what is the equivalent resistance. I think it's easy now. I think now you can recognize series and parallel combination. It is not complex now. It is very simple. Tell me, guys, what is the equivalent resistance? I have changed the circuit, guys. I have changed this connection from this point to this point so that it becomes simple for you. Okay. So now you can easily solve it. How to solve this? First, you can see that this 10 ohm and this 10 ohm are in series. They are in series. So what you can do is, you can replace this entire branch with 20 ohm. You can replace this entire branch with 20 ohm. And this branch is in parallel with this 10 ohm, because you can see that this 10 ohm is again between these 2 points. This 10 ohm is again between these 2 points, and this 20 ohm is also between these 2 points. So what you can do is, you can replace this entire branch. You can replace this entire branch of 20 ohm. Okay, you can replace this entire branch of this 20 ohm. Okay, and you can put it here. Let me change the color, and you can put it here. Is it clear, guys? This is 20 ohm. Okay, this is 20 ohm between these 2 points. It's 20 ohm. Now you look at this two, 10 and 10. This 10 and this 10 are in series. They are back to back connected, and whatever current in this resistance, the same current will flow here. There is no division at this point. So you can say that this 10 and this 10 ohm are in series. So what you can do is, you can replace again this branch by 20 ohm like this. Now you can replace this entire branch with 20 ohm. Now look at this 20 and this 20. If you look at this 20 and this 20, you can see that they are in parallel. They have the same starting point and they have the same end point. So this 20 and this 20 are in parallel. If they are in parallel, they are equivalent. They can be replaced with equivalent resistance, and the equivalent resistance will be 10 ohm. Okay, the equivalent resistance will be 10 ohm. I hope it is clear. They can be replaced with 10 ohm. Okay. Now let's come to this circuit now. You can see that this 10 ohm and this 10 ohm are in series. If they are in series, what you can do is, you can replace it with 20 ohm. I hope it is clear. Okay, so now we have 20 ohm on this side, 10 ohm on this side. This is 10 ohm, and this is 20 ohm. Now can you calculate the parallel of these three resistances, because they are in parallel, they have the same starting point, they have the same end point. So these three resistances are in parallel. If these three resistances are in parallel, now tell me what is their equivalent resistance. Their equivalent resistance will be 1 upon 1 by 10 plus 1 upon 1 by 20 plus 1 upon 1 by 20. So it will be 1 by 5. Okay, I think it's 5, excuse me, it will be 5. Okay, it will be 5. There is one more easy way. We have this 20 and we have this 20. So first take the parallel of these two 20 ohm resistances, no? This 20 and this 20. Okay, you keep this 10 ohm connected like this, you keep this 10 ohm like this. Okay, and what you can do is this 20 and there is one more 20, no? There is one more 20. You can take the parallel of these two resistances first. So the parallel of these two resistances will be 10 ohm, 20 and 20. The parallel of 20 and 20 will be 10 ohm. And now what you can do is this 10 and this 10 in parallel, it will become 5 ohm. Okay, so the answer is 5 ohm. Now you can replace this entire branch with 5 ohm. I hope it is clear. Now these three resistances are in series, you can add them. So the answer is 15 ohm. Answer is 15 ohm. I hope it is clear. So this question was very easy. This question was easy peasy. Okay, I mean you have to start from some point now. So first you have to look which two resistances are in series or in parallel. Start from that point, combine it, and then proceed. Okay, so it's easy peasy. Now let me tell you one more interesting point, guys. Let's say you have n number of resistances like this. Let's say you have n number of resistances like this, R. Equal resistances. Let's say there are 4 number of resistances. 4 resistances, each has the value R, and they are connected in parallel. Now the equivalent resistance will be R by 4. Equivalent resistance will be R by 4. You just divide with the number. If the resistance value are same, then you can divide it with the number. Let's say this 20 and 20, they are equal. So the equivalent value of these two resistances will be resistance itself divided by the number. Number is 2. So 20 by 2 is 10. Okay, so you can write it directly like this. Okay, I hope it is clear. So this way you can take the parallel, and series, and you can calculate the equivalent resistance. But there are some situations where it is not easy to find which two resistances are in series and which two resistances are in parallel. There are some complicated circuits. There it's not easy to find, it's not easy to recognize. Let's take this circuit. Wait a minute, let me rectify this. Okay, at this point, let me rectify it. It is like this. Okay, so now we have this circuit. In this circuit, it's not easy to tell which two resistances are in series, which two resistances are in parallel, because the circuit itself is very complicated. If the circuit itself is very complicated, and if you are not able to recognize which two resistances are in series and which two resistors are in parallel, then you can use one method we call path method. Okay, what is this path method? How to apply this method? Path method. Whenever the circuit is complicated like this, if it's not easy to recognize which two resistances are in series and which two are in parallel, then we use this method, path method. Now the question is how to apply the path method. To apply the path method, what you need to do is you have to name the node point. You have to put the naming of the node point. This is the node point, 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 this is the node point. These are the node points. These are the junction or node, you can say. What is the meaning of node? The point where two or more than two branches meet. We call it node. Okay. So at this point you can say that 1, 2, 3, 4 branches are meeting. That's why it's a node point. It's a node point. It's a node point, node point, node point, node point. So these are the node points. So now what we can do is we have to name these node points. The first step is the step 1. Step 1 is naming. नामकरण करना पड़ेगा दोस्तों. Naming करनी पड़ेगी. Now how to do the naming process? It's very simple. If this point is A and this point is B, this point will also be B. because it is connected directly. If it is connected directly, if this is B, this will also be B. Now let's call it C. Why I am calling it C? Because there is a resistance in between. If this is A, this cannot be A because there is a resistance in between. So let's name it C. If this point is C, this point will also be C because it is directly connected. If this point is C, this point will also be C because it is directly connected. If this point is C, this point will also be C because it is directly connected. Now call this point as D. You cannot call this point as C. Why? Why you can't call it this point as C? Because you can see that there is a resistance in this side, there is a resistance in this side, and there is a resistance. I mean, the direct connection is not given. That's why I call it D. I name it with some other letter, D. Okay. I hope it is clear how to put the naming. I call it A. This point is B. If this point is B, this point will also be B. Now this point will be C because this is not directly connected. This is not directly connected. So that's why I call it a different name, C. If this point is C, this will also be C because it is connected directly. Similarly, this point will also be C because it is connected direct wire. It is connected with the help of direct wire. That's why if this point is C, this point will also be C. If this is C, this will also be C because it is connected directly. But this will not be C because there is a resistance in between. There is a resistance in between, and that's why I call it D. Okay. Now, once you name this point, now step number 2. Step number 2 is modify the diagram, simplify the diagram. Simplify the diagram. How to simplify it? It's very simple. Use the path. First of all, you have to neglect some resistances. Those resistances which have same name on both sides, it will not participate in equivalent resistance. This resistance, on the both sides you have CC point. On the both sides you have the same name. Any resistance which has same name on both sides, that resistance will not participate in equivalent resistance. So you have to remove this. Okay? You have to remove it. Okay? Now, let's start from A. Let's start from A. You have to simplify the diagram. Now, how to simplify? You start from A. From A, there is a 10 ohm resistance. And you have reached to the point number C. You have reached to the point number C. And this resistance I have covered. So let's put a sign here that I have covered this. Okay. Now from C to B, you have 10 ohm. From C to B, you have 10 ohm. Let's call this point as B. From C to B, you have 10 ohm. So this resistance is covered. Okay. From C to B, we have shown 10 ohm. Okay. This 10 ohm I have shown from C to B. So this resistance is covered. Now come to this resistance. Again, it is from C to B. It is between these 2 points, C and B. So you can write it like this, 10 ohm. 10 ohm from again C to B. So I have covered this resistance. Fine. Now let's come to this resistance. This is from C to D. So what you can do is, you can show this resistance with a different color. From C to D, there is a 10 ohm from C to D. Okay. So I have covered this resistance from C to D. There is one more resistance from C to D. There is one more resistance from C to D. Okay. This is the C point. No? So C to D. I have connected one more resistance, C to D. And there is one more resistance from C to D. There is one more resistance from C to D. Okay. Again, there is one more point from C to D. I hope it is clear. So that C to D I have covered. So I have covered all the resistances. I have taken all the resistances. There is no connection between D and B. There is no direct connection between D and B. That's why you cannot connect this D to B, because there is no direct connection. Now I need to calculate equivalent resistance between A and B. If you want to calculate equivalent resistance between A and B, this will not participate in equivalent resistance. Why not? This will not participate in equivalent resistance because it is not connected to B. It is not connected to B. I hope it is clear. So if you want to calculate equivalent resistance between A and B, then this 10 and this 10 are in parallel. So the equivalent of these two resistances is 5, and that 5 will be in series with this 10. So the answer will be 15 ohm. Answer will be 15 ohm. Tell me guys, is it clear? Have you understood it? Say yes or no. Tell me guys, is it clear? So the answer has to be 15 ohm. Tell me everyone. Is it clear, guys? Tell me. Tell me. You want to solve one more question? You want to solve one more question? Okay. Let me give you one more question. Let me give you one more question. Let's say I have a circuit like this. Let's call this point as A and this point as B. And every resistance is of 10 ohm. Every resistance is of 10 ohm. We need to calculate RAB. Every resistance is of 10 ohm. We need to calculate RAB. How to calculate RAB? RAB. Tell me, guys, how to calculate RAB? We need to calculate the equivalent resistance between A and B. Do it fast. Let's see how many of you can solve it. We need to calculate RAB. Do it fast. Do it, everyone. Do it fast. This is a simple question. This is a simple question. Do it fast. Do it fast. I'm giving you 2 minutes, not more than that. Now it's difficult to see which two resistances are in parallel and which two are in series. It's difficult. So what you can do is you can use the path method. If you are using the path method, then you have to apply. You have to do the process. I mean, the first step is naming. After naming, you have to simplify the diagram. Okay? Simple. Do it fast. Do the naming process. Do it fast, everyone. Do the naming process. And you can easily solve. Do it fast, everyone. Okay, I think time over. Look at this. If this point is A, this point will also be A. And this point will also be A. If you call this point as B, this point will also be B, this point will also be B. Okay? Now, let's call this point as C. Okay? Because this point cannot be A. Let's call it C, point number C. Okay? This point is C. Now, what about this resistance? These two resistances are in series now. You can see that. But this resistance is starting from A and end at the point A itself. So tell me, will this resistance participate in equivalent resistance? Will this resistance participate in equivalent resistance? Answer is no. It will not participate in equivalent resistance. So you can neglect it. Okay? You can neglect it because the starting point is same, the end point is same. A to A. It is 20 ohm, but the 20 ohm has same point on this side and same point on this side. So you can neglect it. It means it will not participate in equivalent resistance. Okay? Now, let's simplify the diagram. You start from A. You start from A. From A to B, you have this 10 ohm. From A to B, we have 10 ohm. A to B, we have 10 ohm. Okay? So I have shown this 10 ohm. From A to B, we have 10 ohm. Similarly, from A to B, we have one more 10 ohm. From A to B, we have one more 10 ohm. Okay? This resistance is covered. Now from A to B, we have one more 10 ohm. From A to B, we have one more 10 ohm. Okay? We have one more 10 ohm. This 10 ohm is covered. Okay? Now from A to C, we have 10 ohm. Okay? Now from A to C, we have 10 ohm. Okay? A to C, we have 10 ohm. This resistance is covered. There is one more resistance from A to C, 10 ohm. One more resistance from A to C. Okay? 10 ohm. Fine. This resistance I have covered. A to C. Now from C to B, we have 10 ohm. From C to B, we have 10 ohm. From C to B, we have 10 ohm. Okay? This resistance I have covered. From C to B, we have 10 ohm. So every resistance I have taken care. Okay? Every resistance is covered now. Every resistance I have covered. Now we need to calculate the equivalent resistance of this circuit. I think it's easy peasy. 10, 10, 10. They are in parallel. Three resistors are in parallel. So you can replace this entire branch with 10 by 3. So what you can do is from A to B, these three branches can be replaced with 10 by 3 ohm. Okay, 10 by 3 ohm. Now look at this, 10 and 10. This will become 5. 5 in series with 10. 5 in series with 10 will become 15. It will become 15. Is it clear, guys? It will be 15. Now tell me, so we have this 15 in parallel with 10 by 3. We need to calculate the equivalent. So 15 into 10 by 3 divided by 15 plus 10 by 3. So you can cancel this. It will be 50 divided by 55 into 3. I hope it is clear. So what you can do is you can cancel with 5. So it will be 30 divided by 11 ohm. 30 divided by 11 ohm. Is it clear, guys? I think it's easy peasy. Now it's easy peasy. Okay. So I told you how to simplify this circuit and how to calculate the equivalent resistance. It's very easy. I hope it is clear to everyone. So there are some circuit in which it is difficult to check, difficult to analyze the circuit. Which two resistors are in parallel, which two are in series. So what you can do is you can always apply the path method. Okay. You can always apply the path method, check which two resistors are in series and parallel, and you can simplify the diagram and you can solve it. Okay. Let's come to the next thing. Next thing is infinite ladder. Okay. So there is one more case in which we will try to understand infinite ladder situation. Let's say there is an infinite ladder and we need to calculate the equivalent resistance of infinite ladder. How to calculate the equivalent resistance of infinite ladder? Again, it's very simple. How to calculate equivalent resistance? Look, this is infinite ladder. It is up to infinite. It is up to infinite. Okay. Now what you can do is you can calculate the equivalent resistance easily. But before that, let me teach you how to calculate that. Let's say you have a chain. This is the chain that you use to, इसको आप बेल्ट बोलते हो ना, बेल्ट या चेन बोलते हो, जो कुत्ते को बांधने के लिए इस्तेमाल करते हैं. ठीक है, let's say we have a chain. Okay, can we apply this path method to any type of resistive network, sir? Yes, you can apply any type of circuit, but the problem is, let's say this circuit. In this circuit, obviously you will not apply the path method. Why? Because if you are naming the node A, B, C, D, E, F, G, H, I, infinite nodes are there. That's why it's not possible to solve this circuit using the path method. Okay. So if the circuit is finite length, if the circuit is of finite length and you are not able to see the connection, the series and the parallel, if they are not visible to you, then you can apply this path method. You can simplify the diagram and you can easily solve it. But there are some situations where you have to understand some other methods also. Let's say this circuit. It's an infinite ladder. So in infinite ladder, how to calculate? You cannot apply the path method. Now, how to solve it? It's very simple. Let's say you have a chain. You have a chain like this. In this entire chain, let's say the length is infinite. The length is infinite. And there are some small rings which are connected like this. Okay. There are small rings. We used to tie the dog with the help of this type of ring. Okay. So let's say this is the chain. And its length is infinite, and it contains small rings. It contains small rings like this. Now, can you tell me, if I remove this first ring, what will be the length of this chain? If I remove this first ring, let's say I remove this ring. Now tell me, what is the length of this? The first ring I have removed. The first ring I have removed. Now tell me, what is the length of this chain? Is it infinite, still infinite or less than infinite? Tell me, guys. Is it still infinite or less than infinite? From some infinite length, if you remove one small length, obviously the length will again remain same. It means the length will be infinite again. Length will not change. It's like, let's say we have a sea. From sea, if you take some water out, the water level of sea will not change. Okay. So exactly the same thing you can apply here. It is of infinite length. If you can remove this first string, the length will again remain the same, infinite. Now, in the above circuit, you can apply the same analogy. You can assume the rings. This is the one ring, 2, 4, again 2, 4. So this is the second ring, again 2, 4. It is the second ring, third ring. It is the fourth ring. It is the fifth ring. So there are infinite rings connected like this. Because the repetitive branch I call it ring. The repetitive branch I call it ring. Okay. So there are infinite rings in that ladder. Okay. Let's say their equivalent resistance is X. Let's say the equivalent resistance of this infinite ladder is X. Now what you are doing is you are removing the first ring. If somehow you remove the first ring, and from this ring onward, if you look at the equivalent resistance, what is the equivalent resistance from this point onward? Tell me guys. From this point, if you remove this first ring, and if you are looking from this point onward, what is the equivalent resistance? What is the equivalent resistance? Equivalent resistance will again be X. Okay. So what you can do is, we know that if I am looking from this point onward, the equivalent resistance will be again X. Because if you remove the first ring, equivalent resistance will not change. Now what I can do is, I can replace this entire ring with X. And then I connect this first ring, it has to be X again. Okay. Because we know that the total equivalent resistance is X. If I remove the first ring, then the remaining ladder has the resistance as X. Okay. This remaining ladder has the equivalent resistance as X. So we can remove this entire ladder with the equivalent resistance as X. So the new circuit will be, this is 2, this is 4. From these 2 points, this is the infinite ladder and the equivalent resistance is X, and the total resistance has to be X. Total resistance has to be X because we have assumed that the total resistance is X. From this point onward, again, the resistance has to be X, okay, and the total has to be X also. So now you can calculate the series parallel and equate it to X and then calculate the X value. So what you can do is you can take the parallel of this 4 and X. So the parallel of 4 and X is 4X divided by 4 plus X. Whatever the parallel equivalent of these two resistances in series with 2, that entire resistance will be equal to X. I hope it is clear. Now you can find the X value. X has to be positive. Okay. Now you can find the X value. So you can calculate that X has to be equal to 4 ohm. It will be a quadratic equation. Take this 2 on the other side. So it will be X minus 2 on the right side. It will be X minus 2, and on the left side, you have 4X divided by X plus 4. So you just cross multiply and calculate the value of X. So answer has to be 4 ohm. Is it clear, guys? So the question was very easy peasy. The question was very easy. So you have to understand the concept of infinite ladder. I mean, these are the rings. These are the rings. Equivalent resistance is X. I have assumed that the equivalent resistance is X. If you are looking from this point onwards, if you remove this first ring, let's say you are not looking at this first ring. If you are looking this infinite ladder from these 2 points, again the equivalent resistance will be X. So what you can do is you can replace this entire infinite ladder with X, and the resultant has to be X also. So you can calculate the X value. Is it clear, guys? Is it clear? Now let's come to the next question. Let's modify the question. Let's try to change the question. Okay. Again, I am taking infinite ladder, but now I am changing a little. Okay. I am changing the question a little. Let's say the question is like this. Let's say the question is like this. Again, it's an infinite ladder. Up to infinite. 2, 4, 1, 2, half 1, 1 by 4, 1 by 2, 1 by 8, and again here it is 1 by 4, and then again it's 1 by 16. Okay, so these are the resistances value. We need to calculate RAB. Tell me, guys, what is RAB? What is RAB? Try to calculate RAB. Can we have negative equivalent resistance? For this circuit, you can't have negative resistance. But there are some circuit whose equivalent resistance can be negative. And those circuits must contain dependent sources. you will study this point later when I will teach you about Thevenin resistance in Thevenin theorem. Then you will understand that RTH can also be negative. Okay, I mean the equivalent resistance can be negative, but then the circuit must contain some dependent sources. Okay, but this circuit doesn't have dependent sources, only resistances are connected. It means resistance can never be negative now. Okay, अब्दुल इंडक्टर और कैपेसिटर को बहुत डिटेल में एक्सप्लेन कीजिए सर, आगे की क्लास में इसमें ज्यादा डिफिकल्टी होती है. हाँ जी, मैं अच्छे से एक्सप्लेन करूंगा, डोंट वरी. टेल मी गाइस, व्हाट इज RAB? व्हाट इज द इक्विवेलेंट रेजिस्टेंस बिटवीन A and B? टेल मी हाउ टू सॉल्व दिस क्वेश्चन. नाउ रिमेंबर, this is not repetitive ring. Okay, the rings are not repetitive, so you have to be careful. You have to be careful in this question. Tell me guys, how to calculate RAB? Can you calculate RAB? Do it fast. Do it fast. Let's see how many of you can solve it. Do it fast, everyone. Do it fast. And don't forget to like this session. At least make the 50 of likes now. At least make the 50. At least 50 likes should be there. Okay, don't forget to like this session guys, at least. Okay guys, can you tell me what is the equivalent resistance RAB? I think it's easy, but before this question, let's solve some other question. Let's take one question like this. Let's say I have a circuit like this. Let's say I have the circuit like this. 2 ohm, 4 ohm, 2 ohm, 2 ohm. Now, can you tell me the equivalent resistance? What is equivalent resistance RAB? Tell me guys, what is equivalent resistance RAB? Tell me the equivalent resistance of this circuit. Tell me guys, what is the equivalent resistance of this circuit? Do it fast. Let's see how many of you can solve it. What is the equivalent resistance of this circuit? Can you tell me? Equivalent resistance of this circuit. Can you tell me guys? Tell me. What is the equivalent resistance? सर नेगेटिव रेजिस्टेंस हो सकता है, नेगेटिव हो सकता है, बट नेगेटिव रेजिस्टेंस होने के लिए जरूरी है कि सर्किट के अंदर कोई डिपेंडेंट सोर्स हो, बट इसके अंदर कोई डिपेंडेंट सोर्स नहीं है, ना ही पिछले क्वेश्चन में कोई डिपेंडेंट सोर्स था, इसलिए नेगेटिव रेजिस्टेंस इस सर्किट का नहीं हो सकता. ठीक है, जिस भी सर्किट का नेगेटिव रेजिस्टेंस होगा उसमें डिपेंडेंट सोर्स होना चाहिए. अगर किसी सर्किट में डिपेंडेंट सोर्स है तो उसका नेगेटिव रेजिस्टेंस हो सकता है. ठीक है, बट यहां पर तो पॉसिबिलिटी ही नहीं है उसकी, क्योंकि यहां पर डिपेंडेंट सोर्स है ही नहीं. आगे चल के मैं पढ़ाऊंगा आपको ये सब चीजें, और उसका मीनिंग क्या होता है, नेगेटिव रेजिस्टेंस का क्या मीनिंग होता है वो भी बताऊंगा. ओके, नाउ लुक एट दिस क्वेश्चन गाइस. सो द इक्विवेलेंट रेजिस्टेंस ऑफ दिस क्वेश्चन इज 2 and 2 are in series. It will be 4 in parallel with 4, it will become 2 plus 2 4. So answer is 4 ohm. It's easy peasy. Answer is 4 ohm. Now what I'm doing is I'm using the same circuit. But what I'm going to do is I'm going to divide these resistance values with some constant K naught. I'm going to divide each resistance with some constant K naught. Can you tell me the equivalent resistance now? Each resistance is divided by the same value. Can you tell me the equivalent resistance now? Tell me guys, what is the equivalent resistance now? Tell me what is the equivalent resistance now? Do it fast. Can you tell me the equivalent resistance now? Tell me everyone. Can you tell me the equivalent resistance now? Do it fast. What I have done is I have divided each resistance value with K naught. So now the equivalent resistance will be 4 by K naught. Yes, that's correct. You can see that 2 by K naught plus 2 by K naught is 4 by K naught. In parallel with 4 by K naught, it will become 2 by K naught. In series with again 2 by K naught. So the answer is 4 by K naught. Now, the moral of the story is, if you are dividing each resistance with some factor, then the equivalent resistance will also be divided by the same factor. If you are multiplying each resistance with some factor, let's say K naught, then the equivalent resistance will also be multiplied with the same factor. Okay, just remember this point. Okay, I hope it is clear. So if every resistance is multiplied or divided by some factor, then the equivalent resistance will also be multiplied or divided with the same factor. Okay, I hope it is clear. Now let's come to this question. Let me remove this. Okay, there is no need for this. There is no need for this now. Okay, so let's remove it. So I told you one story. Now I am going to apply that story. Let's say the equivalent resistance of this infinite ladder is X. Now what I'm going to do is I'm going to divide each resistance with 2. Okay, if I divide this resistance with 2 and this resistance 2, it will be like this: 1 ohm and 2 ohm. This resistance will become 1 by 2. This resistance will become 2. This resistance will become 1. This resistance will become 1 by 4. And this resistance will become 1 by 2. This resistance will become 1 by 8. I hope it is clear, guys. So what I did is, I divided each resistance with the factor 2. If you have divided each resistance with the factor 2, then the equivalent will become X by 2. What do you say? Is it clear or not? Is it clear or not? Tell me, guys. This point is A and this point is B. If the equivalent resistance of this is X, what I did is I divided each resistance with the factor 2. Okay? This will become 1, this will become 2, this will become 1 by 2, this will become 1. So each resistance is divided by the same factor. That's why the equivalent resistance will also become X by 2. I hope it is clear. Okay? Now it's very interesting circuit. Why it is interesting? Look at from this point onward. Look at this ladder from this point onward. 1, 2, 1 half, 1, 1. The same ladder is this ladder. If you look at this carefully, 1, 2, half, 1, 1 by 4, the same ladder is written here. It means you can replace this entire ladder with X by 2. Okay, so the resultant circuit will be, this is 2 ohm, this is 4 ohm. Now this can be replaced with X by 2. This entire ladder can be replaced with X by 2, and the resultant has to be X. Is it clear, guys? Tell me. Is it clear? Tell me, everyone. Tell me everyone, is it clear or not? Is it clear? So it's not necessary that every time you will see the rings, the repeated rings. It's not like that. Every time you will not see the repeated rings like this. It may be possible that there is kind of GP, there is kind of some same factor, I mean the constant factor you are dividing. This factor is divided with 2, then you will get this. Again divided with 2, you will get this. Okay? So you will get like this. Okay? So it's not necessary that repetitive rings will be there. So you can use this method. I hope it is clear. So now you can take the equivalent of 4 and X by 2, and then take 2 ohm in series, and the equivalent has to be X. Okay? You can calculate the X value. Tell me, everyone. Is it clear or not? Now you can calculate the X value. What is the X value, guys? Tell me. First you have to take the equivalent of this 4 and X by 2. So 4 into X by 2 divided by 4 plus X by 2. Okay, this is the equivalent of these two resistances plus 2. Plus 2 is this resistance, because this resistance will be in series with this combination. So 2 plus this is equal to X. Now you can calculate the X value. I think this is the calculation part. You can solve it easily. Please find the X value. It's your part. Let's come to the next question. I want to solve one more question. I want to take one more question. Are you ready? Tell me, guys. Tell me, guys. Are you ready for the next question? Are you ready for the next question? Okay. So let's take one more question. Let's take one more question. Now, what I have is, I have this question. Okay, so it's an infinite ladder now. It's an infinite ladder. It's going up to infinite. We call it A and B. This is A, this is B. What I'm doing is, let's say this is 3, 4, 2, 2, 4, 2, 2, 4, 2, 2, 4, 2, and again it's repeating. We need to calculate equivalent resistance RAB. Tell me guys, what is RAB? What is RAB? What is RAB? Now, here the things are repetitive, but you have to be careful. You have to be careful. At starting, things are not repetitive. At starting, they are not repetitive, but after that, it is repetitive. So you have to be careful. While calculating the equivalent resistance, you have to be careful. Tell me guys, how to calculate this? Do it fast. Do it fast, everyone, do it fast. Let's see how many of you can solve it. Do it fast. Do it fast. Let's see how many of you can solve it. And don't forget to like this session. Those students who have not liked it, please like this session. Okay, this will be Guru Dakshina. Okay, I think it's my turn. Now this question is easy peasy. But if you look at this 3 ohm and this 4 ohm, this is not repetitive. So why are you looking at 3 and 4? Just skip these two resistances. I will add these 3 and 4 after calculating the equivalent resistance of this point onward. So let's calculate the equivalent resistance from this point onward because it is repetitive. 2 to 2. No, it's not repetitive. Wait a minute. Wait a minute. From this point onward, it is repetitive. From this point onward, it is repetitive. You can see that the 2, 4, 2, 2, 4, 2, 2, 4, 2. It means this first part is not repetitive. So what you can do is, you can take this out. 3, 2 and 4. Okay? 3, 2 and 4. 3 ohm, 2 ohm and 4 ohm. You can take it out. Okay? 3 ohm, 2 ohm and 4 ohm. You have taken it out. Now, you are left with this 242, 242, 242. Let's assume that the equivalent resistance is X. Now, you are left with this letter 242, 242, 242. Okay, you are left with this letter now. 242, 242, 242. Okay, you are left with this letter. Now let's say that the equivalent resistance is X. Now if you remove this first string, after removing the first string, if you look at this letter, again the equivalent resistance has to be X. So now what I can do is I can say that there is 242, 242. I have removed this first string and I can replace this entire letter with X. And the equivalent resistance will also be X. Is it clear, guys? The equivalent resistance will also be X. Is it clear? Tell me, everyone. So first you need to calculate this X. You need to calculate the equivalent resistance of this letter onward, X. And then connect that X between these 2 points. Okay? You can connect that X between these 2 points to calculate RAB. Is it clear, guys? Tell me. 3 to 4, it's I have taken it out now. Separate. I have separated this because it is not repeating. So the thing which is not repetitive, I have taken it out. Now I have this letter 242, 242, 242. So I need to calculate the equivalent resistance of this letter first. 242, 242, 242. So I have assumed that the equivalent resistance is X. Now what I'm doing is I have removed this first string, and after removing, if I look at this ring again, if I look at this letter again, the equivalent resistance of this letter again is X. So what you can do is you can replace this infinite letter with X, and the equivalent will also be X. Okay? Now you can calculate the X value. How to calculate the X value? So you can calculate the X value like this. 4 and X will be in parallel. So 4X divided by 4 plus X. Plus this resistance and this resistance plus 4. 2 plus 2 is 4. Because this and this are in series. So whatever the parallel of these two resistances in series with 2 and 2. Equivalent will be X. I hope it is clear. First you have to calculate this x value, and that x value you have to connect it here between these 2 points. Between these 2 points you have to connect that x, okay? And then you can calculate RAB. Tell me guys, will you do it for me? Tell me everyone. You want me to solve this question? I think it's easy peasy now. I think you can solve it easily now. Tell me everyone. I think now you can solve it. I think it's easy now. Tell me everyone. I think it's easy now. Tell me. I think it's easy. I think it's easy now. Okay, so you can do it from this point onward. First calculate x. So you have found the equivalent resistance of this entire ladder. Replace that x between these 2 points and then calculate RAB. Now it's easy peasy. Please check your answer and you can comment, you can give the answer in the comment section. Let's come to the next thing. And the next thing is balance bridge or Wheatstone bridge. Wheatstone bridge. Now what is this Wheatstone bridge? Whenever the resistances are connected like this, let's say the resistances are connected like this. And this is a bridge, okay? Let's say the resistances are connected like this. Let's call it A point and let's call it B point. This is R1, this is R2, this is R3, R4, and here you have R0. Now we call this bridge as balance bridge. When we call this bridge as balance bridge, when R1 by R2 is equal to R3 by R4. This is the condition 1. In condition 2, R1 by R3 is equal to R2 by R4. This is condition number 2. There is one more condition. R1 by R4 is equal to R3 by R2. Which condition is correct? Tell me guys. This is the condition number 3. Which condition is correct for balance bridge? Tell me, which condition is true for balance bridging? In which condition, under which condition we will call it balance bridge? Tell me guys, under which condition we will call it balance bridge? Tell me everyone. Under which condition we will call it Wheatstone bridge or balance bridge? Is it condition 1 or condition 2 or condition 3? Tell me guys. Under which condition we will call it balance bridge? Tell me everyone. Tell me. Under which condition we will call it balance bridge? Answer is condition number 1 and condition number 2. Because condition 1 and condition 2 are same. Condition 1 and condition 2 are same. Why? Because R1 by R2 equal to R3 by, you take this R3 down. Okay, so R1 by R3 equal to R2 by R4. So condition 1 and condition 2 are same. Now why these conditions are true and how to remember it? Okay, how to remember this condition? It's very simple. To remember this condition, it's very simple phenomena. What you can do is you always take the ratio of connected resistances. Now you can see that R1 and R2 are connected at this point. R1 and R2 are connected at this point. And R3 and R4 are connected at this point. So you can take ratio of R1 and R2. So on this side you have to take ratio of R3, R4. Now if you can see that R1 and R3 are also connected at this point. R1 and R3 are also connected at this point. So what you can do is you can also take ratio of R1, R3 because they are connected now. They are connected at some point. So R1 by R3 has to be equal to R2 by R4. That is also true. But you cannot take R1 by R4. You cannot take R1 by R4. Why? Because R1 and R4 have no common connection. Okay. R1, these 2 points are for the R1 and R4 is connected at between these 2 points. So there is no common point. Is it clear guys? R1 and R4 are not connected at anywhere. Okay. That's why I am not taking R1, R4 ratio. So it's just a trick to remember. It's a trick to remember which 2 resistances I have to take. The connected resistances I have to take. Whether you take R1 by R2, then you have to take R3 by R4. Because R1 and R2 are connected at this point. So you can take the ratio of these 2 resistances. Similarly, you can take R1 by R3 because these 2 resistances are connected at this point. So connected resistance should be taken. Okay. And you can take this ratio. If you are taking these 2 resistance, then R1 by R2 has to be equal to R3 by R4. We call it balance bridge or Wheatstone bridge. If the bridge is balanced, if the bridge is balanced, you can always remove this middle resistance. You can always remove this middle resistance while calculating the equivalent resistance. While calculating the equivalent resistance, you can remove this middle resistance. Now you can see that R1 and R3 are in series and R2 and R4 are in parallel, are in series again, and the combination itself is in parallel. Okay, R1, R3 are in series, R2, R4 are in series, and the combination itself is in parallel. So you can calculate the equivalent resistance like this. Sir, R0 में दोनों साइड से करंट एंटर हो सकता है क्या? नहीं, मैं करंट की बात नहीं कर रहा हूं अभी. Why I'm not discussing about current? Why I'm not saying that the potential at this point and this point will be same? Because you don't know how to calculate the potential. That's why. After nodal, I will tell you that if the bridge is balanced, then at this point and this point we have same potential. If the potential at this point and this point is same, then the current inside this in this resistance will be zero. That's why you can remove it. Okay. So we'll discuss that at later stage. But for the time being, just remember, if these conditions are satisfied, either this or this, then you can remove the middle resistance. You can remove the bridge resistance, okay? And you can calculate the equivalent resistance easily. Let's take an example. Let's say I have a circuit like this. Let's say I have a circuit like this. This is 2 ohm, this is 4 ohm, 6 ohm, 12 ohm. Now can you tell me the equivalent resistance between the point A and the point B? Tell me guys. And this is, let's say, 5 ohm. Can you tell me the equivalent resistance between A and B? Now you can see that 2 by 4 is equal to 6 by 12. Okay. So this ratio is same, na? 2 by 4 is equal to 6 by 12. This ratio is same. If the ratio is same, you can remove this middle resistance. You can remove this middle resistance, okay? You can remove this middle resistance. Now you can see that this 2 and 6 are in series and this 4 and 12 are in series. Now what you can do is you can take it 8, you can write it like 8 ohm, okay? This is 8 ohm and you can write it like 12 plus 4. 12 plus 4 is 16 ohm, okay? And you can calculate the equivalent resistance. Is it clear, guys? Okay, I hope it is clear. So if the bridge is balanced, you can always remove the bridge branch. You can always remove the bridge branch. It's easy peasy. Okay, I hope it is clear. Now let's move ahead. Sometime it is possible that the bridge is not balanced. Let's say the circuit is like this. 3 ohm, 3 ohm, and there is one more 3 ohm. This is 6 ohm, this is 12 ohm. Now tell me, this point is A, this point is B. Now tell me, is it a balanced bridge? Tell me guys, is it a balanced bridge? 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 Answer is no. This is not a balanced bridge because 3 upon 3 is not equal to 6 upon 12. 6 upon 12 is half and 3 upon 3 is 1. Okay. So this is not a balanced bridge. This is not a balanced bridge. It means you cannot remove this 3 ohm. If you want to calculate RAB, you cannot remove this 3 ohm. You have to take care of this 3 ohm also. Now how to calculate the equivalent resistance? This is not a balanced bridge. Now in this case, how to calculate the equivalent resistance? It's difficult. Now there is one method we call star delta conversion. That you need to apply, star delta conversion. Okay, here you need to apply star delta conversion. Now what is the star delta conversion? We will discuss it in the next class. Star delta conversion. Okay, we will discuss this in the next class, but before leaving the class, I'm giving you one homework. I'm giving you one homework. Okay, you have to solve that homework. So this question can be solved using the star delta conversion. I'll discuss this conversion, the star delta conversion in the next class. But there is one more topic I want to tell you about equivalent resistance in the next class, and that is how to calculate equivalent resistance of symmetric structures. How to take equivalent resistance of symmetric structures. Okay, that we will also take care in the next class. Okay, so now let's stop the class here, but there is one homework question, and the homework question is about infinite ladder. You have to solve this question. Okay, and the question is like this. Question is like this. You have to calculate the equivalent resistance of this infinite ladder. Up to infinite, okay, up to infinite. It is up to infinite. Every resistance is of 4 ohm. Every resistance is of 4 ohm. Okay guys, you have to calculate the equivalent resistance of this infinite ladder. Every resistance is of 4 ohm. You have to be careful. Don't make any mistake. Don't make any mistake. Every resistance is of 4 ohm. Okay, so this is your homework. This is your homework. You have to give the answer in the chat section. Okay, in the comment section you can put your answer. And in the next class, in tomorrow's class, we will discuss about star delta conversion, and I will try to teach you about the symmetric structure also. But that symmetric structure, I think I should skip for the time being, because that symmetric structure case will be easily understandable after nodal. Okay, so we can understand the symmetric structure equivalent resistance after nodal analysis. Okay, so in the tomorrow's class we will discuss first about star delta conversion, and then we will start with the new topic, that is basic laws. Okay, so let's stop it here guys. I think you enjoyed this session, so don't forget to watch it again. Okay, and don't forget to share this session to your friends. Please tell your friends that we have started a new series, and in that series we will try to cover the entire subject, and I'm teaching from the fundamentals itself. Okay, so don't forget to recommend to your friends, and so that they can also attend this series. And there is one more series, and that series is experiment and beyond. I have recorded some experiment lectures. You can also watch those lectures. You can search experiment and beyond. So it's highly recommended that you need to watch lecture number 1, episode number 1, in which series? Experiment and beyond. Experiment and beyond. There is one series, experiment and beyond, on BYJU'S Exam Prep. Okay, you have to search experiment and beyond by Ashu Sir. Okay, by Ashu Sir. You can search this series on YouTube, and you have to watch episode number 1. This is your homework. Okay, in that I have performed some experiments. Believe me, you will enjoy this episode, and you will understand these concepts very well. Okay, because you will learn the practical application of these concepts. Okay, so that's all for today's session guys. I hope you enjoyed, and in the next class we'll discuss about basic laws and some other topic like स्टार डेल्टा कन्वर्जन. ओके, सो आज के लिए इतना ही करते हैं दोस्तों. नेक्स्ट क्लास में फिर से आपसे मुलाकात होगी. अपना ख्याल रखिए, पढ़ते रहिए, मुस्कुराते रहिए, बट एक काम करके जाना है आपको, एंड दैट इज डोंट फॉरगेट टू सब्सक्राइब अवर चैनल, लाइक दिस सेशन एंड प्रेस द बेल आइकन. There is one more thing that you need to do, and that is there is one mobile app. Okay, go to the Google Play Store, install this mobile app. There also you will find some free lectures, so you can enjoy those lectures also. So that's all for today's session. See you tomorrow. Take care. Bye.